Okay, this is Math 2. We're in Chapter 1, and we're going to do number 5, 7, and number 8 in this video. And then the back side we're going to do on the other video. So on number 5 it says, on graph paper, graph the line MU for M negative 1, 1, U 4, 5, and then calculate the slope, write the equation of the line. Calculate MU, or the distance from M to U. Are there any similarities to the calculation used in part A and B, and are there any differences? So, first things first, we need to actually get a graph on here. So, please get yourself some graph paper. Because you will need it for this entire course, so you might as well just go get yourself a graph notebook or a packet that has some graph paper on it, or graph paper loose leaf, whatever you want to call it. So for the first one, let's see, we're going to be negative 1 and 1, 4 and 5, so probably going to be somewhere close to the first quadrant, or somewhere around or in the first quadrant. Let's see. Okay, and then we have negative 1 and 1, so negative 1 and 1. Here's point M. And then we have point U, which is at 4 and 5. 1, 2, 3, 4. 2, 3, 4, 5. And here's point U. Okay, so the first one says calculate the slope of MU, so we're going to go from left to right. Our slope triangle looks like, let's see, we go up, right, so slope is change in Y. Slope is going to be change in Y over change in X, right? So how much did we go up from M to U? How much did we go across or to the right from M to U? So to get from M to U, we're going to go 1, 2, 3, 4, 5, 6 up, right? We're going to go 6 up, and then across, we're going to go 1, 2, 3, 4, 5. All right, so our slope is going to be 6 over 5. And then the bigger question is, what is the equation of the line? So if you actually took a pencil and drew a line that goes through M to U, just like that. Well, you already have your slope, right? The only question is, where does it actually hit at that point right there? And you don't know. Well, so far you don't know, because I don't want you to estimate. This is not a third. I don't know what that is yet. It's really odd, right? It's not in the middle. It's not, you know, a third of the way. It's not a quarter of the way. The question is, how are you going to figure that out? And the best way to do that is to take your slope, take one of these points, and plug it into your equation for y equals mx plus b. And that way, if you find you have your 2 points, you have your slope, you're missing b, because b would tell you where the intercept is, right? That's your starting value. And then you can work it out. So if you want to pick a nice easy point like negative 1, 1, this is going to be like your x and your y. And you already have your slope, 6 over 5. As far as I know, it's 6 over 5, right? Let's double check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay. So we're going to plug in. So y is going to be 1, right? Because we took it from this point down here. Your slope is going to be 6 over 5. X is going to be negative 1, right? There's your y, there's your x, plus b, we don't know, so we're just going to leave it as b. All right, so 1 is equal to negative 1 times 6 over 5 is just negative 6 over 5, because negative 1 times anything is going to give you that same thing back, but, well, with a different sign. So plus b, and we're going to add 6 over 5 to both sides, plus 6 over 5 to both sides. So 1 and 6 over 5 is going to be your b. And that's not your final answer, obviously, because we didn't actually write the equation of the line yet. Your final answer should be y is going to be equal to 6 over 5x plus 1 and 6 over 5. that's technically your final answer. If you don't like it in a mixed number like that, you are more than welcome to change that to whatever it is you want, as long as the value is still the same. Okay, that is the equation of your line. And then calculate mu, or the distance from M to U. The distance from M to U is not a slope. Slope is the direction. Slope tells you which way to go, like north, south, east, west. Distance would be like, how far is it from M to U? It's not 6 over 5. 6 over 5 what? That doesn't make any sense. So in order to do this, you technically, hopefully, have some knowledge from last year that in order to find the distance between 2 points on a number line, you can either do the distance formula, if you are familiar with that. If you're not familiar with that, then do the easy one. Literally, the easiest thing in the world is to, well, create a triangle, which is what we did in the first place when we were doing the slope triangle. And you have a distance from M to this corner up here, which was our 6, and then from here to here was 5. You have a right triangle. I'm hoping that you notice this, because technically a vertical line and a horizontal line will always make a right triangle. And then, will always make a right angle, not a right triangle. So now your M to U is going to be the hypotenuse of your right triangle. So technically, side squared plus side squared, or leg squared plus leg squared, should give you your hypotenuse squared. So your setup should look like 6 squared plus 5 squared should give you your hypotenuse squared. And solve for that and get the hypotenuse by itself. If you don't like using h for the hypotenuse, you're more than welcome to use x squared if you'd like. 6 squared plus 5 squared, and then solve for x. Solve for x, not x squared. You should not get something like 100 and something something, okay, or somewhere less than 100. It should be a pretty relatively easy number to digest. It will be a decimal, by the way. That's fine, round to 2 decimal places. Okay, and then the question on part C asks, are there any similarities to the calculation used in parts A and B? So what numbers did you use to actually calculate the slope? What numbers are you using to actually find the side length on the hypotenuse? So it all just depends on, how you look at it. But there are similarities and there are differences. Okay, that was number 5. Number 7, you should know how to do. So I'm not going to do this. If you still have issues solving questions that look like this, please see me during lunch. It'll take 5 seconds of your time. Okay, number 8, we have Angela has a rectangular piece of paper, cuts the rectangle out of a corner shown at the right with the area and the perimeter of the resulting shape. So there are several ways to do this. One way, to be honest, is to figure out what the missing pieces are. If this is 16 and that's 9, it's going to be 9 up to here, so the remainder of this whole thing up here is going to probably be a 7. Right? Hopefully that makes sense to you. 7 plus 9 is 16. And this part is 9. And it's got to kind of sort of match up with this one, right? So how do you find the area of this piece right here, right? The area of a rectangle is just base times height. And then if this part is 7 centimeters, this part's going to be 6, right? Because if you drop this down right there, you're good to go. And then 21 minus 6 is, I have no clue. I'm subtracting this on the calculator, 15. So this part's going to be 15 centimeters up here. So your perimeter is add up all the outsides, and your area is find the area of the boxes inside. So base times height. You should be able to handle that one on your own. Number 18, I was going to do in the other video, or 16. What am I missing? I'm missing 16. I'm skipping 16 for some reason, but I don't know. I'll do it in the other video.